All right, let's talk about the one invisible problem that makes almost every AI agent, especially the ones that work in your browser, just fail. It's this deep, fundamental flaw that can make even the smartest AI feel fragile and unreliable. And it all boils down to one single, really dangerous assumption.
So here's the million-dollar question, right? You see all these slick demos of AI agents booking flights or filling out complex forms, but the second you try it yourself, it just breaks. It falls apart. Why? The reason is actually shockingly simple, and it all comes back to that one bad assumption. Okay, this slide right here, this is the whole problem in a nutshell. On the left, you've got the open-loop system. This is how pretty much all traditional automation works. The agent clicks a button, gets a little message back that says, "OK, true." And it thinks, great, success. But here's the lie. That only means the command was sent. On the right, in a closed-loop system, OK, true means something totally different. It means the result was actually verified. And that tiny difference, it changes everything.
Now here's the kicker. The scale of this problem is just wild. It's estimated that a whopping 90%, 90, of all AI agent failures come from this one little misunderstanding, this false success. The agent thinks it did its job, but in reality nothing happened. Or, even worse, the wrong thing happened.
The source material for this explainer just nails it with this quote. It says, "OK, true" means click was dispatched, not action has worked. This is the automation lie, right there. The agent gets told, hey, I sent the signal to click the button, and it just moves on, totally blind, with no idea if that click actually logged you in, submitted the form, or did anything at all.
And this is what we call the automation lie. I love that term. Or maybe a better way to think about it is the dispatch and hope model. The agent sends a command out into the void, like click this button, and then just crosses its fingers and hopes for the best. It has absolutely no way to confirm the outcome. Did it work? Did it fail? The agent is clueless.
So how do we fix this mess? Well, the solution is a totally different way of thinking. It's called the closed-loop system, or CLS for short. And instead of just shooting commands into the dark, CLS treats every single action as a verifiable state transition. It's not about, did I send the click? It's about, can I prove that the click successfully changed the website from state A to state B?
So what the heck is a closed-loop system? Think of it like a smart assistant that doesn't just do what you say, but actually checks its work. It creates a feedback loop. First, it makes sure an action is even possible. Then, it does the action. And then, this is the most important part, it verifies that the action did what it was supposed to do before it even thinks about taking the next step. It's this constant cycle. Act, then verify. Act, then verify.
Now this is super interesting. A closed-loop system doesn't just see the world in black and white, success or failure. It introduces this critical third state, indeterminate. This is for when the system isn't totally sure what happened. It's basically the agent raising its hand and saying, I clicked the button, but I can't confirm the outcome. And that is a huge, huge leap forward. Admitting uncertainty is way safer than just blindly assuming you succeeded.
Okay, but for a system to be this smart, to actually verify stuff, it needs to know what's going on, right? It can't just operate in a vacuum. It needs context. And that context is built on what the source calls the 4 pillars of knowledge. So let's break these down. First up, you've got PKS. That's basically answering, how do I do stuff around here? It's the agent's memory of how websites work. Next is OK, or operational knowledge. That asks, what's the situation right now? Is the user logged in? Is there a pop-up on the screen? Then there's the goal register, which answers, what am I trying to accomplish? It keeps the agent focused. And finally, operator notes, which just answer, what should I remember for next time?
Let's put that in even simpler terms. PKS, that's the agent's playbook, its long-term memory. OK is its eyes and ears, what's happening right now. The goal register is its to-do list, making sure it doesn't get distracted. And operator notes? They're literally just digital sticky notes for itself. All 4 of these work together to give the agent the context it needs to make smart and, more importantly, verifiable decisions.
All right, so theory is great, but how does this actually work in the real world? How does the agent use all this knowledge? Well, it all comes down to this really cool mechanism called guarded commit points.
Think of a guarded commit point as a bouncer at a nightclub, but for the agent's most important actions, like logging in or submitting a payment. You can't sneak past it. Before you get in, before the action happens, the bouncer checks that everything is in order. Those are the preconditions. And after the action, it confirms you actually made it inside. That's the successful outcome. Only then can you proceed.
And this right here is maybe the most important rule of the whole system. No silent fallback to open loop. What that means is, if the bouncer isn't sure, it doesn't just shrug and let the action happen anyway. No way. The whole process stops. The system raises an alarm and forces a resolution. There are no silent failures here.
And here are some real-world examples of these guarded actions. Look at guarded login. The precondition is simple. A login form has to be visible on the screen. And the success condition, it's not just that you clicked login. The system checks that you are actually logged in and that the login form is now gone. Or for guarded submit form, it first checks that the fields are filled out correctly. And then it looks for proof of success like the URL changing or a thank you message popping up.
So when you pull it all together, what are we really talking about here? We're talking about a fundamental shift in how we build these things. We're moving away from a system that's built on pure hope to one that's built on pure verification. And that's a genuine paradigm shift for AI agents.
And the result of that shift is profound. You go from a brittle script that breaks if a button moves 1 pixel to an agent you can actually trust. You go from blind execution to verifiable results. It's the difference between celebrating, hey, I sent the command, and confirming, yes, the action actually worked. And because it's verifying outcomes, it creates a self-correcting system that can actually learn from what works in the real world.
And that really brings us to the final, and I think most important question. As we start handing over more and more of our digital lives to these AI agents, if their actions aren't being constantly verified, can we ever really truly trust them with anything that matters? Based on what we've talked about today, I think the answer is pretty clear. Thanks for joining this explainer.